Good afternoon, sir.
Hi, Davia. How are you doing?
Tired, sir.
Oh, Jesus. How are you doing? You cook the soup again?
No, sir. Work and school. Too much.
Yeah, I know. I know. This too shall pass, honey. Trust me. Nothing lasts forever. This too shall pass, my dearest. So push on, push on, push on. Are you
Yes.
studying though? I recognize nobody not doing no work on Edicus often.
Sir, I'm
Not
going to start
one.
tomorrow, sir. It's just that last week we had a lot of assignments and mid-semesters this week, I should say, yeah. So all of that passed now, so I have some time to work my Edicus off.
Okay. Pass me. Listen, nothing at all.
Sir,
Yes, please.
sir, by next week we finish, man. I can't have a lot to
Yes.
do. I start.
Nesta boo.
Yes, sir.
You don't make me put the cross on like my beating the Nesta.
No, sir, let me tell you, by next week I can say, Bomba, so she done quick.
All right, then cool. Make
All right.
sure because I mean I'm looking at it and I'm saying to myself, I was saying to my wife earlier that oh my goodness, imagine I gave them time last week to do the work and nobody not do the work. Nobody not do the work. No vex, but I forgive the two of you. I don't know the others. I'm gonna say Ramesh has terrible headaches and trust me, I know what those are. I am the I am the one who have these headaches. Trust me, when I have headaches, sometimes it lasts me for 1 week because I don't take tablets. So I know what it is that he's going through. But what I want to happen though is that I really want to see some energies, something moving with um with the work online. All right, so we are too strong. 24 past. We are too strong. Let us see how much we can cover now, and then maybe we can just I can give you some assigned tasks to do, and then we move on from here. I did Newton Rampson. I did McLaren's with you. I am a little concerned about the differentiation. Well, not true. I'm very concerned about the differentiation. I don't think you guys are where you're supposed to be. So on screen, you'll see me project an example of the differentiation. We're going to go through this example together and we're going to see how best we can pick up and move into. I want to do today, look at one or two more examples of Maclaren's expansion, but also I want to do some approximations with you. All right, very important. Okay, so it says we look at the product rule: the first times the differential of the second plus the second times the differentiation of the first. The first times the differential of the second plus the second times the differential of the first, or product rule. And here we have the first, and here we have the second. So whenever I call the first, I write it back. Whenever I say the second, I write it back. So the first, so I'm going to put back the 2x minus 4, which is right here, times the differentiation of the second. When I differentiate the second, is an exponential function. The differential of an exponential function is the exponential function itself times the differentiation of the power. So it is going to be e raised to the 7x plus 1, see it right here, so, times the differentiation of the first, of the power. And when I differentiate the power, 7x plus 1, I'm going to get 7. So that's why I have the 7 right here, times 7. Plus the second, I call the second, so I'm going to write back e to the 7x plus 1. Right here, so, times the differentiation of the first. When I differentiate the first, differential of 2x minus 4 is 2. So I'm going to have 2 right here. Now that the differentiation is finished, the differentiation is hold on a minute, please. The differentiation is finished here in blue. So I'm going to fix up. And in fixing up, what I'm doing is to say, removing the multiplication signs right here. So this is going to be 2x minus 4 times e to the 7x plus 1 times 7. See here, so all of this piece here, so is this. Then I have my plus sign, 2 times my e to the 7x plus 1, which is right here. Not finished yet. Because there's something that is common between them. What is common, sir? What is common is...
I can go pick up it, sir. But take my last year.
Take your time and look at that, and then when you finish, look at it, you tell me.
All right. Yes, sir. I understand. I get. Can.
All right. So now what is going to happen is I am putting all of these together. And then I'm going to see what is common here, that is common there, and you recognize that the e to the 7x plus 1 is common. So I'm going to factor out e to the 7x plus 1. See here? I'm taking out e to the 7x plus 1. What is going to be left? 7 times 2x minus 4 is going to be left on this side, and only 2 left on the other side. See here? 7 times 2x minus 4 and plus 2 on this side. And then now I'm going to be fixing up what is on the inside of this bracket. 7 times 2x is 14x. 7 times negative 4 is negative 28. And I carry out my plus 2. So I'm going to have 14x minus 26 times e to the 7x plus 1. And that will be my answer. That will be my answer. Now, I want you to try for me, as a review, the question number 8. Try for me as a review, question number 8. So look at number 8 is a product rule, the first times the differentiation of the second, plus the second times the differentiation of the first. The first times the differentiation of the second, plus the second times the differentiation of the first. Try that for me, please. I give you 3 minutes, 5 minutes to just try that quickly.
Sorry, I think we finish.
All right, good job. What about the other two?
No, sir.
All right. Take your time, but hurry up. If that make any sense to you. Give me a minute, please. All right. Deja, did you get that answer? I projected the answer. I'm not sure if you saw it.
No, we never get that. So what if I get a different answer?
Deja?
Yes, sir. What if you get 3x squared?
Hello, somebody? Anybody? One somebody? Two somebodies?
Are you hearing me?
Sir, I kind of get it right, sir. I do want something wrong. I kind of miss it. I get the
Hello?
concept. Can
Ready? Sorry. Ready? Go. Stay still, nice on the water. Look at that one. The wall back on the surface. Can you see those kids rolling over the surface? He's not too high on the water. Hold on. He's not too high on the water. Going far.
Hello? Anybody hear me?
yes, sir.
You guys finished? You guys finished? All right, let me try this again. Are you guys hearing me?
Yes, sir.
Can you respond again, please?
Yes, sir.
Okay, wow. Whew. Did you all hear me long time? Because I have been,
Yes, sir, we hear you, but me have talk I never that in.
I wasn't hearing you at all. All right. So were you able to do the question 3 and no, were you able to do the question 4, sorry? 6 over 2, 2x plus 1?
Yes, sir.
Anybody had a difficulty with that one? Already is just a revision of our differentiation, because when we get into the McLaren's is going to require us to do a whole lot of differentiation. I don't know what function you're going to be given, and if you don't know how to differentiate the function, you're going to be having problems. So how are we? If you don't talk to me, guys, I won't know. So I'm asking you the question, how are we?
Getting there, sir. It wasn't as hard as it is.
Okay, all right. Let me give you this one here now to see if you can manage this one now. A question like this with the ln function is a question that they can give you for the McLaren's. And for the Maclaurin to the ln function, you have to differentiate multiple times, over and over and over and over and over again. So I really want you to get into the habit and the practice of differentiating. Is very, very, very important. So let me give you 5 minutes on this one, and just let me know when you are ready, and I'll post the answer, and then we can have a conversation about it. Please, I want everybody to participate in this. It don't make sense to move back into the Maclaurins with you guys not understanding fully the differentiation, and I think that was missing for class week before last. All right, so 5 minutes. Go ahead for me now, please. Start. Are you finished, guys? You guys are working slowly.
Austin, you have a question? One question?
See? You're not answering me again.
Yes, sir.
Are you finished?
Yes, sir.
Okay, so I'm hearing you, Nesta. Is there anybody else in the class that is finished? I don't like where this is going. Um, I get the feeling that you guys are not doing what I'm expecting you to do. I need to hear somebody outside of Nesta. Hello, somebody?
Yes, sir.
Okay. I really don't like where this is going. I'm not enjoying today's class at all. Nesta, that's what you got for your answer? If no, let me know, please. I can go through it with you.
So I'm never get the 6.
But you got the x cubed minus 5?
Yes, sir.
All right. You got the x squared in the numerator?
Yes, sir.
All right. So this is x cubed minus 5 all squares, and you're asked to find dy by dx. So we're differentiating. We're differentiating, they ask us to find dy by dx. Now what is happening is I have, it's a logarithmic, differential. So how you know it's a logarithmic differential? Because it has the ln function there. It has the ln function. So what needs to happen is that, remember always, when you're differentiating the logarithmic function, the differential of ln x is always what? Tell me, the differential of ln x is always what? You guys not talking to me, you know? When
Well, sir.
when I differentiate ln x, what do I get?
Sir, 1 over X.
Yeah, so why it took so long for you to respond? Come on, man. Well, I've been doing this revision since almost an hour now. I've been doing this revision. Yes. So when you differentiate ln x, you're going to get 1 over x. So the differential of ln x is 1 over x. So when you're differentiating the logarithmic function, you're going to have 1 over x. But importantly, you now have to differentiate what x is and multiply it by the reciprocal of the function. Follow me? So let's go. So you have ln x cubed minus 5 all squares. So when you're differentiating, it's going to be 1 over x cubed minus 5 all squares. You saw the first part is easy to get. Can you look at the first part and tell me if you have the same thing? You can see where I get the 1 over x cubed minus 5 all squares?
Yes, sir.
Yeah, man. Because what it is that you're doing, you're just reciprocating the function. So you have ln of something, you're just going to put 1 over it. So it's going to be x cubed minus 5 all squares. All right? And then now the difficult part comes now when you are differentiating. What rule are we using to differentiate this one here? What rule are you using to differentiate?
Sir, the first times. Also?
I want to hear the rule. I gave you 4 rules. Which are the 4 rules we're using to differentiate here?
Product rule, sir.
Not the product rule. Go again.
Quotient Rule.
Not the quotient rule. Go again. The quotient rule is only used when you have what? Tell me. We're not ready for the exam, you know? We're not ready for the exam. When you are differentiating, the quotient rule is only when you're differentiating what type of function?
So, sir, the power rule then.
Yes, it is a power rule. Thanks for answering that. But my question still remains. When do we use the quotient rule?
When you multiply the coefficient by derivative.
No. You use a quotient rule when you are differentiating a rational function or fraction. You have the numerator and denominator. You ever hear me say that before?
No, sir. I'll make a
You,
record.
you've never heard me say that when you're using a quotient rule, you have to use that. You must be using a fraction. If it's yes, it's yes. If it's yes, it's no, it's no, you know. So you've never heard me say that, right?
Never,
Unless,
no, sir. Keep
okay,
on, sir.
understand. Okay, no problem. So let me just bring you back to the. No, you said no, man. You said no already. So let us go. Let us go. The quotient rule. See there? It says. Read it for me, matter of fact. I'm not going to read it. You read the quotient rule for me.
The denominator times the differential of the numerator.
Numerator. Mm-hmm.
Differential of the denominator all over the denominator square.
Mm-hmm. So when you have a denominator and you have a numerator, what function you have? It's a fraction for me. All right. So let me ask you now. Um, then you have a numerator and a denominator. What does that suggest that you have? What do you know? Talk to me. Can somebody say a fraction for me, please?
Fraction.
A fraction. So tell me, how then are you going to say that you never know that when you're using the quotient rule? You're using a fraction. I want somebody to tell me that. You see the point I'm making right there?
Yes, sir.
Yeah, man. Alright, let me just pause and just say something here because I'm a little concerned. I am not going to be giving up my Saturdays. Literally giving up my Saturdays to teach students who are going to end up failing an exam. Oh, hell no. No.
You don't feel that?
Well, guess what? The rate at which we're going there is, I am not even a happy camper. And you know, let me just put it out there. I want me to be on record for this. So, moving from last school year, when this school year started, I was still marking summer papers. When second semester started, I was still marking first semester papers. I made a conscious effort this semester to finish marking the papers before. Now I still have some receipt papers that are supposed to be battling. So technically I'm still marking papers. What's the point? I moved from one school year into the other school year, into the other school year, into the other school year, into the other school year. And I was just feeling burnt out. So when I asked you for the time last week, was literally to get you guys, to give you guys a break. One, I could get a break number two, but while you are getting a break, at least you get a break to complete some assignments. There's one student who spent 5 minutes plus on the tutorials. Some students have not even logged on to EducaSoft. Only 4 students out of the class have logged on to EducaSoft. So when I'm looking at that in the course of this week, I feel discouraged. I mean, I came to class today feeling very discouraged. Very discouraged. And week before last when we met, and I was going through the Maclaren's expansion, I recognized the deficiency. What was the deficiency, sir? Differentiation. Because Maclaren's is an application of differentiation. And I recognized the deficiency. And I said to myself, all right, I'm not helping the students if I don't really get some differentiation in. So I decided that, you know what I'm going to do? I'm going to do some differentiation with them. So today was just to be a revision of the differentiation and then move into the Maclaren's. But at 2:34, an hour and a half into the class, I'm still at the revision. And I don't even feel comfortable getting out of the revision. I'm asking questions, and it's the same person or persons answering, and I don't know. I'm not getting a good feeling at all about this. And it's not a lot of you know. It's not a lot of you. But I'm not getting I'm not getting the energy. I'm not feeling it. I'm not feeling it. You guys are not doing any work. And if you're going to waste the money in the summer or waste my time in the summer, let us call it off. Trust me. If you don't plan to do the work, let us call it off. Let us just say, you know what, sir? I could do this come second semester of that. The only reason why I requested this is because there are some students who need to graduate. And in graduating, they need to get this course out of the way. And I said to Mrs. Campbell, for the sake of those who are completing, I don't want them hold back just for the calculus to make a run a fast track. And I said, I want to do this something because it's the time of the afternoon. I'm supposed to be getting my beauty sleep at this point in time. Or going to do my normal exercise work. But I've given up that to be with you guys. I'm not feeling the energy. And I have to tell me, because if this is how we're going to go for the rest of the time, I'm not come back next week. So you have to let me know where I keep. I'm waiting, I'm listening, guys.
Sir, we're not class, we're not feel, sir.
Yeah, Shin.
We're interested. Let me speak for myself. I'm just really busy and tired.
Yes, honey bunches, but guess what? I understand that, and that's why I am not so hard and fast with you. You don't complete the assessment. All right, fine. But the mere interaction in class, are you understanding? Sorry, I'm moving to the chat. Are you understanding? I'm not hearing you guys. Then I hear Nesta respond,
Yes.
and then the rest of you I'm just not hearing. And I, if I were to use my last year summer group as a benchmark, I had 12 students in the course with me last summer. 12. And all 12 of them passed. Never had this conversation with them about answering questions and so. Matter of fact, you used to have to tell them, say, all right, stop answer questions. And if you don't believe me, look into the YouTube channel for summer 2021 because you have access to all my lectures. Sometimes I have to say, all right, come, let's get back. Because we have robust conversations in class. Now I'm struggling just to hear somebody's voice. I don't like it. I don't like you. I don't like it. I don't like it. And I know that there is a problem. I know say, 100 with the course yet. And I'm trying to help you to get to that place of confidence. What on now work with me? So I need to hear from you guys. What is the issue? You want us to continue? You want us to what can be done differently? Is it how we teach? Like how we teach? What is it? I mean, let me know because I need to know so I can reach you guys. I don't think I'm reaching you. Talk to me.
Sir, good evening. I'll ask you a question. If we go through the tutorials and educate off, right? Because what is there is aligned with our course outline. Because I was thinking if we go through that, will we undo the assignments outside of class? Will we be prepared good enough for the exam?
Absolutely. My best users to the platform never fails.
Okay.
Never fail.
I have been trying to focus more on that because what I realize that you have some of the things That all right, you might teach it one way, but Educosoft showing the same thing a slightly different way. And I think that for me it caused a little confusion for me. So what I've been doing is trying to focus more on Educosoft.
And that's a bad thing to do. And let me just pause it right there and say to you, I've often and always said to my students, look at how I am doing the stuff, because what I try to do is simplify what is presented on Educasoft, simplify what is being done in class, simplifying everything, so that when you go to do the pieces of work, you are in a better position. Educasoft, think of, you ever read a textbook yet, Maurice, and understand where the textbook is say?
Well, yeah, yes, sir.
Okay, right. But if a teacher now comes and takes that same textbook and go through what you have read multiple times, don't it make a difference and you understand it more?
Well, that is true.
Yeah, right. So this is what I'm saying. So Educasoft is there as a support guide. So you come to class, I present the topic to you, you go, you look at the tutorials on Educo, and then you attempt the questions, etc., etc. And the point I'm making is that I have given you recordings, I have given you my worksheet, like what is projected on screen. I've given you Editasoft. I have given you all the things that I want you to have so that you are in a position to succeed. I'm trying everything. And plus, you have me on the WhatsApp group, right? You have me, the WhatsApp group, and the other classmates to say, if you not understand something, I fling a question in the chat, somebody is going to respond to you, teacher or otherwise. But I just want you guys to, and I mean, mark you. I remember last week when Chanel says, "Sir, I'm working on the road. I can't make it to class."
I'm
And
working this week too.
same thing. And
I
Chanel,
know.
I'm going to tell you, when you sent me that message, I have been toying with the idea. Lord, should I? Shouldn't I? Because I drove down to the North Coast the night before. And I said, I'm just going to lay down and relax. And then I said to myself, to go into the class session. And I said, you know what? I've already done this. Let me just go. Only can do the work. And so, but students, I really want you to be able to be done, to do a little bit more.
What?
I'm not hearing you, sir. You're breaking up.
You're breaking up, sir.
Oh, sir, sounds.
No, sir.
Oh, not understand what I say.
Let me eat about 5 minutes. I don't know what is happening. Let me eat about 5 minutes. I'll soon come back.
Did I talk to Junior?
Are you guys hearing me better now? No? Anybody hearing me?
Yes, sir.
All right, any better?
Yes, sir.
All right, nice. What I recognize is that sometimes there's an interference with the connectivity, so you just hit a little break and then it comes back. All right, so let us just get this. So do we have an agreement now that going forward, when we just do what is expected of us, we can have that agreement, right?
Yes, sir.
All right, good. Thanks. All right, now, so I was saying to you earlier that when we're talking about the quotient rule, it only deals with a fraction. How you know? See it here, denominator, numerator. The others don't have anything, no denominator, no numerator. So you know that the others is not the quotient. Quotient only deals with denominator, numerator, so forth and so on. All right?
Sir, you did share this PDF with us?
I've been sharing this stuff. I mean, this is revision for today's class, but I have been sharing PDFs with you, but I won't share this one just yet. All right?
All right, sir.
All right, so just remember now, so the quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. You know this, you're good to go with your differentiation. All right? So let me just look at the natural logarithm again. The differential of the logarithm function is 1 over the function times the differential of the function itself. So just remember, the differential of a logarithmic function is 1 over the function times the differential of the function itself. All right? So just remember, I will have, once I'm given a logarithmic function, I'm going to reciprocate the function. What do you mean by reciprocate the function, sir? Put 1 over it. Put 1 over it. So it's 1 over the function. Whatever the function is, put 1 over it. That is setting you up nicely to complete the question. So 1 over that function. Then now you're going to differentiate the function. Then you're going to differentiate the function. So you have to now differentiate the function. Differentiating the function, you just multiply it. You see, I put times in uppercase because that's all you're doing. You're going to be multiplying it and you're good to go from there. So it's going to be the differential of the logarithmic function is 1 over the function times the differential of the function itself. All right, times the differential of the function. All right, it's very important. Very important. All right, so let me go back to the question of the 6x squared. Nesta said she didn't get this one. And I'm only doing this because Nesta said that she didn't get this one, and then I'm going to move on. So it says y is equal to ln x cubed minus 5 all squares, and you're asked to find dy by dx. You're asked to find dy by dx. It's a logarithmic function, ln function. So how do you know all sorts of logarithmic and ln are the same thing? So it's a logarithmic function. So what is happening is it is going to be 1 over the function, sir. So I'm going to put 1 over the function. Whatever the function is, I don't care. I am putting 1 over that function. So it's going to be 1 over x cubed minus 5 all squares. That's the first part in solving this question. And if you look, you can see it right there. Now I'm going to be multiplying. Remember, when you come to mixed school, you don't use multiplication sign anymore, you use a dot. So your dot is saying that you are multiplying. So it's going to be multiplied now by the differential of x cubed minus 5 all squares. X cubed minus 5 all squares. How do I differentiate this? I have 4 rules. So I'm talking 4 rules of differentiation.
Sorry, I'm breaking up again.
Are you hearing me now?
A little better.
All right, cool. All right, so what is happening is there are 4 rules of differentiation that I've taught you: the chain rule, the product rule, the quotient rule, and the power rule. Quotient rule is if I have a numerator and denominator. The chain rule is if my function is being separated by positive signs and negative signs. My product rule is if I'm multiplying stuff inside of my function. Power rule is when I have parentheses raised to a power greater than 1. Just like this question here, x cubed minus 5 raised to the second power. So once we have a function that is raised to a power greater than 1, it's a power rule. What does a power rule says? I'm going to use the power to multiply the function, reduce it by 1, and then I must multiply by the differential of the parentheses. So what I'm doing is that 2 is when I place in front of the x cubed minus 5, and then I'm going to reduce the power by 1. So the power is no longer 2 but now 1 because I reduced it by 1. That's what differentiation is. Differentiation says that I'm subtracting 1 from the power. But now I must differentiate what is inside the parentheses. I must now differentiate what is inside the parentheses. And the differential of x cubed minus 5, the minus 5 is a constant, and the differential of a constant is equal to 0. When I, however, differentiate x cubed, I get 3x squared. So I'm multiplying everything by 3x squared. So what I now have is 1 over x cubed minus 5 all squares times 2 times x cubed minus 5 raised to the first power times the differential of inside the parentheses by 3x squared. Differentiation finished right there. All I'm going to be doing now is just to fix up my differentiation. Fix it up. So 2 times 3 is 6, and 6 times x squared is 6x squared. And that is being multiplied by x cubed minus 5. So I'm going to have 6x squared times x cubed minus 5 in the numerator over x cubed minus 5 all squares in the denominator. And this one, the one in the numerator here, well, I have everything spelled out here. The x cubed minus 5 raised to the first power in the numerator will be cancelled with one of the x cubed minus 5 all squares in the denominator. So all I'm going to be left with in the numerator is 6x squared over x cubed minus 5. Is that understood? There you go again. I'm asking a question. Are you hearing me?
Yes, sir. Yes, sir. Yes, sir.
So respond to me now, man. That are the same thing we just talking about. All right. Are there any questions? But you're not seeing that you want me to go over.
Sir, can you go back over the third line, please?
All right. All right. Go over the third line. Which third line? This one here. I see my cursor.
No, sir.
All right. The line. Okay. The second dy by dx you want me to go over, right?
Yes, sir.
All right. So what I'm saying to you is when I'm differentiating the logarithmic function, the function that looks like ln is not in, is not in. Some people call it in function. It's not in. It's ln. Capital L, common n. The natural logarithmic function, the rule is you're going to reciprocate it, meaning you can put 1 over the function. It is 1 over the function times the differentiation of the function. It's 1 over the function times the differentiation of the function. 1 over the function times the differentiation of the function. It is 1 over x cubed minus 5 all squares times the differentiation of x cubed minus 5 all squares. You see it right here, sir? Who was that? Was that Alton asking the question?
Yes, sir. Not see
Right.
your cursor though, but yeah, I see where you're at. That's where you're at.
Yeah. The cursor don't work. So I don't work on this stuff here. So I can't spotlight like I normally do with the other system. So what I'm saying to you is, having written the function as a reciprocal 1 over, I am now going to be required to differentiate the function. I'm now going to be required to differentiate x cubed minus 5 all squares. But the differentiation of x cubed minus 5 all squares is that of the power rule. Power rule means I can't use a quotient rule. Never can I use a chain rule.
Not so clear, sir. Not so clear, so no, well, just now.
Alright, you get it better now?
Not yet, barely.
Alright. Let me know. I'm going to continue talking and just let me know when I'm clear. Alright?
Alright.
You hear me better now, right?
Gone back there now.
Any better? Any closer?
Yeah, a little better.
Alright, cool. So what I'm saying to you is when I differentiate my power, it's going to be the 2 that I'm multiplying in front of the function.
Yes.
I arrive at the function and I reduce the power by 1. So that's why I say I have 1 right there. So alright, that's why I say I have the 1 right there. And then what is going to happen now is that I must now differentiate the inside of the parentheses.
Yes.
And the differential of x cubed minus 5 is going to be 3x squares.
Yes.
So we have my 3x squares there, and my 3x squares now times the 2 up in top gives me the 6x squares down here. Right.
Okay.
Good. So now what is happening? The 6x squared times x cubed minus 5 to the first power is going to be placed in the numerator. It's going to be placed in the numerator. Why, sir? Because it doesn't have a, whenever you multiply a fraction by a whole number, the position of that whole number that you're multiplying the fraction by will be the numerator. Right? Because remember,
you're getting muffled again, sir.
Okay. Alright. I apologize for my unstable internet access.
That is.
Any clearer now?
Yes, clear now. Yes.
All right, great. So what is happening now is that I'm going to end up with 6x squared over 6x squared times x to the third power minus 5 over x to the third power minus 5 all squares. So I'm cancelling out one of them from the only one from the numerator to one of them in the denominator. So I'm going to be left with 6x squared over x cubed minus 5. I'm going to send you this document afterwards, so you can have a look at it again. But in the meantime, I want you to try this one for me.
All right, sir. No problem.
Number 6. All of you try number 6 for me, please. And when you finish, just let me know. Don't sit and wait there.
Okay.
Are we okay? Are you okay, guys? Any questions? Are you finished?
Okay, sir.
Thank you, Nestor.
Almost, sir.
All right,
Almost.
all right, cool. Shortly. How is stay? How is stay? I'm not hearing anybody. How is stay?
Finish.
So when I tell you when you finish, must let me know, man. What you got for your answer?
So I will text it in the
Oh, you texted to the group. Let's stay in a know me already, man. Got that, Mister? You're not talking to me, Mister.
Sir, so I
I'm
make
here.
a mistake again. So
Can
I'm
you?
writing about I forgot to put back the something there. So I make
What?
a mistake.
Did you? Where was the error? Was it the differential of
Sir,
the inside of the parentheses?
no, sir.
Yeah.
Uh,
I want to know where the error was.
sir, where I put the 3, so I put the first line correct, but I never put back the 6x.
Oh yeah, I want to buy the two by the 3 by the 2x.
Yes, sir, I just bring back down the 3, so I put 3x instead of 6.
Okay, all right. So just work on that one. The rest of you, I need to hear what is happening.
Yes, sir. I got that, sir.
Thanks, Alton. The rest of you, Maurice, Chanel. Oh, Chanel gone.
Yes, sir, I got it.
So talk to me now. If you squeeze it out, you know. Sure. All right. One last one for the road. No, I don't have any more. I don't have any more there. All right. So, let's go back to the McLarens that we've been looking at, and let me give you another McLarens. We did that one. We did that one. Um, did we do this one here? 2x plus 3 to the fifth. We did that one. Anybody remembers?
Don't remember, sir.
All right. If you don't remember, can you go ahead and do that one for me, please?
Okay.
21st, you can pause.
No, you're sir. No, no, sir.
Any clearer, Nestor?
Yes, sir. Clear now.
Right. So I'm saying I don't want you to frustrate yourself. Do you know what to do in this question?
No, sir.
Okay. Kind of figured. All right. So the question asks us to expand that function 1 over 2x plus 3 using Maclaurin series. Using Maclaurin series. Up to including the term in x to the fifth. Up to and including the term x to the fifth. So I'm going to let f of x be equals to 1 over 2x plus 3. I'm going to let f of x be equals to that, 1 over 2x plus 3. And then I'm going to find f of 0. I have to find f of 0. So anywhere in the original function given, I see x, I put 0. So I'm going to have 1 over 2 times 0 plus 3. 2 times 0 is 0. So I'm just going to have 1 over 3. And then I'm going to have to differentiate the function. Because Maclaurin says that I'm going to look at successive differentiation. In order to get up to x to the fifth, it means that I have to differentiate. When I differentiate and differentiate and differentiate, I'll get the term up to x to the fifth. All right? So I'm going to ask you now to differentiate the function for me. 1 over 2x plus 3 for me. Go ahead and differentiate that function for me, please. I'm giving you 3 minutes. Alright guys, finish with the differentiation.
Yes, sir.
What for the answer? Hmm?
Over 9.
What was that? Hmm?
You hearing me, sir?
No honey.
Sir, I said 2 over 9.
Or 2/9. What about the others?
Third wrong?
I don't know yet. Alright, 2/9 is when you evaluate. I wanted a differentiation. So this is going to be the differentiation. So it's actually negative 2 nines. Next door, you're careless with some signs, you know. So I know that you're following, but you're just careless with the signs. Right, Nesty is gone. Maurice and Alton, we're just here together. What does that mean?
All right, sir. I am following up to the negative 2/9.
Mm-hmm.
Trying to understand what it or
All right, so
interpret.
this is the first differential. And when I find the first differential, I'm substituting 0 in it. So that's the aim. The aim is to find the differential of them and then substitute 0 in it. I'm finding the value at the point x equals 0. So having found the first differential and got the negative 2 nines, did you get the negative 2 nines or you got only 2 nines?
Negative 2/9.
All right. Work on the differential for me for the others and let me hear what is happening. Do the differential of this function of the first differential and find the second differential for me. And when you find the second differential, let us see what will happen. Continue working for me, please. I have only 12 in here, so when I forget to talk to me, you know. And I don't know if, to be honest with you, based on how things are going, I don't know if I'm going to go up to 5 o'clock. So right about now, I'm looking at 4 o'clock and give you time to go and finish off some work.
All
Real
right.
talk. Yeah, man, start. Maurice, Alton,
Yes,
and
sir.
nobody called to me. What is it?
Sir, I'm still there
No,
record, sir.
yeah, same with me, sir.
Okay, so you're okay so far with the working out, or is it that because I projected mine, so you're okay so far with the working out, or I want me to do the second working out for you?
No,
So far so good, sir. So
Where
far
is
alright,
working out.
where is
alright,
your
alright. You see the ending part,
Mm-hmm.
finding the derivative, like the
Mm-hmm.
hold on. Alright, the ending part. Alright, for the third derivative, for example,
Mm-hmm.
ending part when you get the 2x plus 3 squared times 2. Um, all right, so that is so that is the that is the
Derivative of the inside of the parentheses. That's what you get.
of the inside. Okay, understand.
Okay. All right. I'm right here. Continue working, please. How we stay? How we stay? How we stay?
So we're to the last part, you know, pretty much after the formula with the f of x plus f dash of x. So just organizing that part.
Very nice. Very nice. Maurice.
We're still on the fifth
Okay. Fair enough. Once you pass the third one, we'll go through and you reach the fifth one, you are moving. Very nice. Continue.
All right, sir.
Sir.
Yeah, we're on.
Yeah, in this last line, like the f of zeros, can I just convert those to decimals and calculate to the calculation? You recommend that? Or okay, 1 over f of 0, f dash of 0. Yeah.
I normally say, are you talking about the 2 over 9 and 8 over 27 and the 6 over 27, those numbers?
Yes, sir.
I often say, don't read like that. Look at how I do. Look at how I do. Look at how I finish up the question. Because this is sometimes when you use a decimal, you know, you throw out some of the values, and sometimes the question comes as a continuation, hence something else. And if your values are off, it can throw off everything else.
Okay.
Good question though. But if I were you, I would stick with the fractional form.
So I'll do just that.
Maurice.
Sir, I'm following.
Yeah, but the
fifth part, you know, but the part after that, I was having some trouble with that.
All right, no problem. All right, so I just want to know that you're talking to me with me. I mean, and you're where we are. All right, so pretty much you're on alternate the same place. So let me just take over from here now. So having done your f of 0, f dash of 0, f double dash, all the way down to f to the 5th dash of 0, and we get all those values. You know, there are several things for you to recognize. If you only do your first value and your second value and see that there's an alternation in the sign, trust me, the alternation will carry right through. So you start off with a plus, then a minus, then a plus, then a minus. So if you recognize you're getting 2 minuses together and 2 pluses together, chances are just double check something. Just double check. Not that you're wrong, but just double check. Because if you do the one first and get a positive, and then do the other one and get a negative, the other one that you do can't be negative. It can't have two of the same signs coming together, except that they have everything in the function that is positive. All right, but let's double check. That's just one thing. Not that it can't, it will never ever happen, but you know, for the questions that you are getting, yeah, it's highly unlikely that we'll give you something like that. All right, let's go. So having found all of those values, I am going to be putting them into the function. Look at my f of 0. My f of 0 goes here, right here, so the 1/3. And then now the second one is going to be f dash of 0 times x.
So remember, we're not seeing your cursor here.
No, man, I'm talking about the one in blue.
Yeah, I know. I'm just cursor right here. I think you're finding that we're not seeing your cursor.
Yeah, hold on there, because I'm supposed to annotations. All right, I'm annotating, but are you seeing the cursor now? Are you seeing the cursor?
Yes, huh? Seeing the cursor now.
All right, good. Let me see if I can spotlight now. All right. All right. And then now, when I get to negative 2 nines, negative 2 nines is going to be f dash of 0 times x. See here? My negative 2 nines is f dash of 0. So the times x right here, so. Then this is going to be f double dash of 0 times x squared over 2. So f double dash of 0 here, 8 over 27. So it's f double dash of x over x squared over 2. Then f triple dash over x cubed over 3, f to the 4th dash. So all of them line up, you know. This one here, the negative 16 over 27, is f to the triple dash of 0 times x cubed over 3 factorial. And then again have f to the 4th dash is going to be 121 over 801. See it here, so? Times x to the 4th over 4 factorial. And you can't go wrong, because you can't have f triple dash x to the 4th. It must line up. So if you have f triple dash, you're supposed to have x to the 3rd dash. If you have x to the 7th dash, it means you're supposed to have x raised to the 7th power over 7 factorial. So it lines up beautifully that it can't go wrong, or it shouldn't go wrong, because it lines up beautifully. And then now, f to the 5th dash is negative 1280 over 243. So negative 1280 over 243. But what is happening is, the negative 1280 of 243 is going to be f x to the 5th over 5 factorial. Because remembering that this 1280 over 243, negative 1280 over 243 is f to the 5th. So if you write it out like that in blue, and I specifically wrote it like that in blue, so you can see what is happening. And then now, what we'll do from there is to write our final answer in red. What's our final answer? Our final answer is us evaluating what is. So this 1/3 is the same thing, so I put it as 1/3. This negative 2 over 9x, I can't simplify it any further, so I put it as negative 2 over 9x. This 8 over 27, hold on, sir. 2 factorial. What is 2 factorial? 2 factorial is 2 times 1. So this is 2, so there's a 2 in this denominator here, so this 2 can cancel with this 2 up here into the 8 and give it 4 times. So we're going to have 4 over 27. 3 factorial, remember, is 3 times 2 times 1, which is 6. and 2 into 6 goes 2 times, and 2 into 16 goes 8 times. So I'm going to have 8 over 27 times 2, and 27 times 2 is 54. No, but again, no, I can't do that. Something not right here, so. 3 factorial is 3 times 2. Right, it's correct. It's 27 times 3, actually. I said 2. 27 times 3 is 81. So I'm correct. And then 4 factorial is 4 times 3 times 2 times 1. 4 times 3 times 2 times 1. 4 times 3 is 12 times 2, 24 times 1. So, and this is 128. So when I do this cancellation, I'm going to end up with 16 over 243. So forth and so on. That's all that there is to it. Really and truly, this topic is not difficult at all, if you were to ask me.
I think it just takes some practice.
And take some time.
Yes.
It takes both practice and time. And if you don't have the two of them combined together, you're going to be in some problems. Now, this ends my unit 1. It's with me there? Unit 1. It ends my unit 1. I really wanted to have moved into the Taylor's expansion. What I'm going to do nonetheless, I'm going to send in the notes for Taylor's. And when I send in the notes for Taylor's, you can go through it. I will speak to you outside of the regular class schedule. But I'm giving you this time, students, this 1 hour of unsupervised work that I want you to go on your EDICO and start completing some assessments. You're going to have a mid-semester, and your mid-semester is going to come from everything that we've done so far, because this ends unit 1 for us. It ends unit 1 for us, and your question can come from, well, your questions will come from everything we've done so far. So this is a good time for you to revise what it is that we've done. Go and tackle those questions on EducaSoft, please. So at least we can get the ball going, because the ball now move yet.
Sir, before you go, right? All right. So you say you were teaching us is you were simplifying what is on EducaSoft. But there are sometimes that really book up on some things on EducaSoft. It just look different. Yeah.
Drop it in my bedroom, Maurice.
Yeah.
So if you see something about EducaSoft and I look too righteous, screenshot it and drop it on the group now so we can explain it.
All right.
Because what I find out is happening, you know, you so far I can tell you reading the tutorials on Educa because I have all that information, empirical data that I have. The others not going on to do nothing. So I see that you have been reading the tutorials. So if you are having an issue, say something, it will definitely help out those other ones who not do nothing.
All right, sir.
All right, so let's try that for me, please.
We'll be going on it shortly, sir. Actually, this was my first class since the fast track start because I was trying to reach out to Mr. Cooney and wasn't getting through, so I missed the other classes.
Yeah, man, you can access those lectures in the YouTube.
Yes, I'll go through those.
All right then. I need to give you access to EducaSoft Alton.
Yes, sir.
All right, so you can start working too. All right.
All right, sir. Thanks.
Take care.
You too.